Good afternoon, Samadhi sir. Shall we start, sir?
Good afternoon.
Sir, so on the behalf of Civil Engineering Department, I, Rohit Kumar, welcomes you all the participants, and Professor Narendra Kumar Samadia sir, the professor in Department of Civil Engineering, IIT Roorkee. Professor Narendra Kumar Samadia sir is currently the president of Indian Geotechnical Society. His area of specialization is geotechnical earthquake engineering, rock engineering, and underground space technology, soil structure interaction, ground improvement techniques. Professor Samadia has done his BE in civil engineering from Ravi Shankar University, Raipur, ME in geotechnic engineering from Rani Durgavati Vishwavidyalaya, Jabalpur, and PhD in civil engineering from University of Roorkee, which is presently IIT Roorkee. Professor Samadia sir has completed 7 funded research projects. He is he has served as a vice chancellor, a vice chairman, GATE 2013, and as a chairman for GATE 2014. He is also the member of various administrative committees of IIT Roorkee. He is also an editor of Indian Geotechnical Journal and member of about 9 technical committees of national level, such as Indian Geotechnical Society, Institute of Engineers, etc. Professor Samadia sir has supervised about 14 PhDs. Professor Samadia sir.
Okay, thank you.
Sir.
So you just stop sharing. I will share my lecture. So good afternoon to all of you.
Good afternoon, sir.
So are you able to see this slide?
Yes, sir.
Yes, sir.
Okay, so the topic of my presentation is advances in ground improvement techniques. Okay, please see the slides are moving or not.
Yes, sir, moving.
Okay. Okay, so thank you so much for giving me this opportunity to share this lecture with the participants. And as I can see, the participants are mostly the teachers. So most of them may be aware of what I'm going to speak now. Okay, so the topic is advances in ground improvement techniques. The question is, now these two photographs will tell you the entire reason, the story, why the ground improvement is required. Now here, this is a very famous case of Leaning Tower of Pisa, and this is the structures which were damaged due to liquefaction during Niigata earthquake 1964. These two are very famous photographs. And here in geotechnical engineering, we learn through the failures. Unless the structure fail, we do not get majority of the information why it has got failed. So if the structure is safe and it is standing, hello, am I audible?
Yes, sir, you are audible.
Yes, sir.
Yes, sir.
Okay. Okay, so there is a saying that judgment comes from good experience. And that is very true for geotechnical engineering. judgment comes from good experience and experience comes from bad judgment. So this is the case of the bad judgment. And from that, we geotechnical engineers gained experience and then tried to design the structure. Not only design, but explore the ground before placing the structure or designing the structure, so that there are less probability of failure. So we know that in the present day, the best buildable lands are not available. So whatever sites which are given to the construction engineers, either are the filled up sites, low-lying waterlogged areas, wastelands, creeklands. And another thing is that we are going for high-rise buildings nowadays. So the design loads are high, not only in the case of buildings, but otherwise also. And the site is situated in the seismic zones. So what are the options available with us engineers? Either we remove the material which is poor in that particular site and replace it with a more suitable material that is going to be expensive, or just we bypass that particular site laterally by changing the project's location, or vertically by use of deep foundations. So either you will have to go for deep foundations if it is deep ground, or you will have to just avoid that particular location. And it is not possible because the land is not available abundantly. So we will have to construct that particular structure at the same location which has been allotted to us. Now, should the design of facility like height, configuration be changed to reflect the ground limitations? So these are the options available. But there is another option which we call it as the ground improvement techniques. That is the fourth option which is available. And it is to fix the poor ground, means improve the properties of the ground and make it suitable for the project needs. So that is the fourth option. Now, if we are using this fourth option, then we will have to decide about the fixing tool. Now here fixing tool means there are a number of options available for improving the ground condition. So out of those options, which particular option we should go for? And there are critical issues associated with all the options, because all the options cannot be used everywhere. Those will depend on the site conditions. So there are various methods, and the function of these ground improvement techniques is to increase the bearing capacity of soil, to control deformations and accelerated consolidation, to provide lateral stability, to form seepage cutoff and environmental control, and to increase resistance to liquefaction. So this particular FDP is about this geotechnical earthquake engineering, and in a major way to increase the resistance to liquefaction. Now, all these functions can be accomplished by modifying the ground's character. Now, it can be done with or without the addition of foreign material. Sometimes you will have to add the foreign material into the ground, or whatever existing, that particular can be improved. So there are various methods which are available, and the methods are densification, consolidation, weight reduction, reinforcement, chemical treatment, thermal stabilization, electro treatment, and biotechnical stabilization. So out of these, I will be discussing some of them. Now, the very old method is ground improvement by densification. This is a very old method, and we know about this. Now, we can go for static compaction or vibro compaction, dynamic compaction, or even in the case of loose sands, we can go for blasting or compaction grouting. Okay. So, with this, the key issues which are related with the densification are mainly is the percentage of fines in the soil, because that will decide which particular method should be used. Ability of the soil to dissipate excess pore water pressure. Now, especially in the case of compaction grouting, if you are going for compaction grouting, and if the soil happens to be soft clay and the permeability is very low, then it is quite possible that during the compaction grouting, this particular soil may fail in shear. Okay, if the excess pore water pressure which has got developed is not dissipated. Now, then energy felt by the soil, how much compactive effort is required. If there are presence of boulders or utilities and adjacent structures, then how are you going to densify this particular strata? And aging. So these are some of the key issues. Now I will not be going for discussion on the static compaction. Now these are the methods by which we can compact, and these are different type of rollers which are used, like seafoot roller, vibrating smooth wheel roller, and pneumatic tire rollers. Now all these are rollers are suitable for different type of soils. Not all type of soils. One roller cannot be used for all type of soils. So for different type of soils, different rollers are. Now there is another method which is being used nowadays, especially for the shallow depth. That is the rapid impact compaction. Now it is a relatively new technique that can be adopted for improvement depth of less than 5 meters. So this particular method is also available for the surface compaction. A very important method which is being nowadays being used is the vibro compaction, which is also termed as vibro flotation. Now, this is nothing but the rearrangement of soil particles into denser configuration by the use of powerful depth vibration. So vibrations are imparted to the loose strata, and naturally this is good for, or you can say best for, the coarse grained soils, especially loose sands. And in this, the combined action of vibration and water saturation. So through the jet, we also add water by jetting arrangements. So loose sand grains, they come in the compacted state. So vibrocompaction is performed with specially designed vibrating probes. So I will show you one of the sketch of the vibrating probe. So both horizontal and vertical modes of vibration have been used in the past. So here, this is given the steps how the compaction is done. That probe is first inserted into the ground by both jetting and vibration, and then after the probe reaches the required depth of compaction, granular material, usually sand, is added from the ground surface to fill the wide space created by vibrator. and a compacted radial zone of granular material is created. So it can be used to support all type of structures, and especially vibrocompaction is not effective if the finer particles are more than 15 to 20%. So that is the condition for the densification. Now, this particular photograph will show you different steps. So it is the probe is actually lowered into the ground, and by water jetting, this hole is created. This material will come out, and then the material is poured from the top, especially the granular material, and by the vibration imparted by this probe, it will become dense, and finally you will get a dense material. So coarse-grained soils are suitable for treatment by vibrocompaction, increases bearing capacity, reduce settlement, and this is very useful for the liquefaction mitigation. Another method is the dynamic compaction, especially for the loose sandy deposits. So here it involves lifting and dropping of heavy weights or pounder onto the ground surface in a repetitive manner. Now you can see the impression of this pounder on the ground surface. So again, when it is dropped on this particular strata, vibrations are generated, and because of that, the denser configuration is achieved. Now, this particular method can be used as I said, for all type of structures. It can be used for the foundations of large workshops or the storage tanks, even the oil storage tanks. Then it can be used for the foundations of airport runways or stability of sandburns in the offshore application. So that is about the densification. Another method is by consolidation. So this consolidation can be achieved by preloading with or without vertical drains, but normally we go for preloading with vertical drains. Otherwise, the time required for the consolidation, a certain degree of consolidation to achieve, that will be very high. Or we can go for electroosmosis. And nowadays, this particular method is being used. I don't have any idea whether it is used in India, but yes, it is being used at several projects abroad. So, with the consolidation, key issues associated are stability during surcharge placement. Let us say you have got a soft clay deposit and you are placing a surcharge in the form of embankment or surcharge in the form of the blocks. It is quite possible that particular stratum may fail. So that stratum should have sufficient strength. So stability during the surcharge placement is one of the issues. Then if you are going for vertical drains, then clogging of vertical drains, that is another issue. So we will have to provide a suitable filter. Then if you are going for vacuum consolidation, then maintenance of the vacuum, that is another issue. I hope you know, all of you know this case of sand drains. Now these sand drains are nothing but the columns of about 20 to 30 centimeter diameter. These are augured into the ground and then filled with the granular material or maybe sand, and then we place a free draining blanket at the top, and then we place this embankment. Now this embankment may be a permanent embankment for a highway or railway, or maybe a preloading and then we can remove this particular embankment once this. So you have got this compressible clay layer, okay? And then because there will be this is the case of the three-dimensional flow. So it is the flow will be taking place in the radial as well as the vertical direction, and then the rate of the dissipation of excess pore water pressure, which has got developed due to this construction, that will dissipate, and in the process, this particular clay layer will get consolidated. So this is how the flow will be taking place. So there will be radial flow also, and that water will come out through the drainage blanket which we have provided to come out of the ground, and you will get a better. Now, in place of sand drains, now there are various other drains are used, like band drain. Now these are nothing but the prefabricated band drain, have an obvious advantage over the sand drains in that its quality and the small cross-sectional area of the band drains. Now this is the person who attempted this first, and in 1948, and after that there are several improvements in the band drain, and prefabricated band drains are being used nowadays, and they have entirely replaced conventional sand drains. So here in this particular table, there are two drain types which are given, like cardboard wick, geodrain, alley drain, castle board, pole burn, flow drain, and nowadays we are using this PVC. Now, some dimensions are given, whether filter sleeve is used, that is also given, and it is country made. Who started first actually this construction and use of these particular band drains. So a small description of different drains like sand wicks. So these are ready-made small diameter sand drains, pre-packed in filter stocking. In early days, woven jute canvas was used as a filter stocking. But presently, polypropylene, woven or melt-bonded fabrics are used as stockings. And cardboard drains, so they are inserted into the ground by mandrel, which are then removed. Okay, channel in the cardboard facilitates the removal of water, easy to install, and nowadays specially processed cardboard are available, so they have longer life and they are very durable. Then nowadays which we are using, that is the PVC, prefabricated vertical drain. It can be defined as an fabricated material or any fabricated material or product consisting of a synthetic filter jacket surrounding a plastic core. So because of their shape, they are also known as band or wick drain. All these details are given in this particular report. Now the installation process, the vertical drains are used where preloading alone shall not be efficient. In that case, we may go for PVC. So vertical drains in soft clay accelerate the primary consolidation of clay since they bring about rapid dissipation of excess pore water pressure. And they do not have direct effect, although they do not have direct effect on the secondary compression. But since this primary consolidation is completed early, so the onset of secondary settlement will be brought about early. So the structures or embankments can be put to use earlier than it would be possible otherwise. So that is the advantage of PVC. Now, it is successful in accelerating rate of flow for fine-grained soils, but they are not so effective in case of organic soils and highly stratified soils, like in case of peat. Now again, you can see this is the process. If you are able to see these white spots like this, these are all inserted PVCs into the ground, and this is the equipment by which we push this particular drain into the ground. Now these PVCs are available in rolls, and these are now inserted into the ground, and finally the PVC inserted ground will look like this. And then we can place that embankment. Okay. Now here, these two figures are showing the preloading without and preloading with prefabricated vertical drain. Now here, if you are not using the vertical drains, then there will be long gauge drainage part, the time required will be more. But here, if you are going for this, so there will be radial flow which will be taking place, and it will accelerate the dissipation of pore water pressure and the process of consolidation. Now, the advantage or the importance of this PVC can be explained using this particular figure, which is given by Nautel. The role of PVDs with preloading. Now, this depends on how much is the thickness of the material, what type of material it is, how much is the permeability of the soil, and all different things. But just for the comparison purpose, now you can see that this particular plot is the time required for degree of consolidation versus the time. Now here, the first one without vertical drain, the time required will be very high. You will need maybe months or years also, depending upon how much is the thickness of the layer. But if you are going for vertical drain, and naturally you will have to design what should be the spacing. This is the plot for vertical drain with 2 meters. So this time has reduced considerably. But if you are going for 1.5 meter, further reduction. If you are going for 1 meter spacing, whatever consolidation has to take place, that can be finished in 4 months or lesser time. So you can put that structure in use as early as possible. So this shows the advantage of the vertical drain. Now there is a case history. This I have taken from ESN, Mr. Ajay Ghosh, who was engineer there in Pune. Now this is the case history for an embankment for this Ernakulam-Kottayam doubling railway line in Southern Railway. Now this is located on Vaikom Road side approach of Kaduturthi River Bridge with height of existing embankment about 3 meters, and another embankment for doubling was to be constructed of having height of 5 meters, just adjacent to this. This is the soil strata up to 6 meter depth, subsoils sandy clay silt with N values ranging from 8 to 12. Allowable safe bearing pressure is 4 ton per meter square at 1.5 meter depth and 12 ton per meter square at 6 meter depth. On construction of full height of new bank, there was failure of the new bank with heaving of ground on the vacant land. So the fill material was removed completely and technical consultancy was taken from IIT Madras. Now, because of this construction of this, the new embankment, 5 meter high. Now you can see the old rail line. There was heaving, and because of that, there was distortion of this particular rail. So what they have done, they have recommended PVDs at 0.8 meter center to center spacing in triangular pattern. Now it can be triangular pattern, it can be square pattern, it can be rectangular pattern. So that we will have to design it properly. So after PVD installation, providing drainage filter and laying high strength geotextile at the base. Construct embankment for 3.5 meter. So out of the total height of 5 meter, they have recommended that you initially construct up to 3.5 meter in stage 1. And when about 75% consolidation, which has taken place because of PVDs in about 1.5 months, this was the estimated, then raise embankment to final height in stage 2. Now, this, how much is the degree of consolidation achieved? So they have to monitor the actual settlement data and also the pore pressure data. So they have gone for these two instrumentation, the two instruments like platform type settlement gauges and then Casig and Ray piezometers. And after this 5 meter high embankment was successfully constructed and the doubling was done. So the preloading methods which are being used can be divided into these two: preloading using fill, or preloading using vacuum pressure, or combined fill and vacuum preloading methods. So we have already seen the preloading by using fill. Now, if you are going for vacuum consolidation, these are preferred when ground is very soft or when the fill surcharge has to be applied in stages. Otherwise, the shear failure of the material will take place. There is no fill, or the use of fill is costly. If suppose the suitable material is not available at the site, then you will have to import it, you will have to transport it, then that becomes costly affair. And there is no space on site to place the fill, and that is also possible that space is not available. So in that case, what we can do, we can go for vacuum consolidation along with the surcharge. Okay, so here this is the photograph or the sketch given by Nee et al. About the vacuum preloading. So here these are the vertical drains which are connected with horizontal drain. Okay, and the vacuum air water through the vacuum air water pump, the vacuum is, so water is sucked by applying the vacuum. So here the design is how much should be the vacuum pressure, how much should be the spacing of all these drains, etc. So in place of preloading alone, we can go for the combination of preloading and vacuum consolidation. Then another method is the ground improvement by weight reduction. The fill which you are constructing, then we may use the material which is less in weight, but it is durable. So placing lightweight material over the native soil in one of the 3 ways: spread in a loose form, then compact it, like we can make use of the alternate layers of fly ash or bottom ash and the natural soil. So we will have to spread it in a loose form, and then we will have to compact it, or cut in block form and then stacked according to a certain arrangement, or pumped in a flowable liquid form. the layers of the earth cover, and then 0.2 meter filter media, and then stone pitching. So we can make use of this type of lightweight material for the construction of the embankment, maybe the highway embankment, or nowadays this particular material, EPS geofoam, it is being used for the construction of the embankment, for the railways, for the bridge approaches, So here, this is the expanded polystyrene geofoam. It is a lightweight, versatile material, and the weight of this material is about 1% of the weight of the soil. If you are going to use soil here in place of this, so the weight is only 1% of the soil and is strong enough to support heavy loads, including railway loads, or you can use it for the approaches of a bridge, right? So we can make use of this lightweight material. Then another ground improvement technique is by reinforcement. Now, the methods of application are mechanical stabilization, reinforcement in the form of nailing, soil anchoring, micropiles, and stone columns or fiber reinforcement. So the key issues affecting soil reinforcement are the load transfer mechanism between the soil and the reinforcing elements. Failure surface of the reinforced soil mass. How will it fail? And another important thing is the strain compatibility between the soil and the reinforcement. Then arrangement of reinforcing elements and durability and long-term behavior. Now, all over India and almost all the cities, you will find that the bridge approach is being constructed by these MSE walls. Now, the concept was given by Biddle in the 60s, and now it is being used. All over the world. So, number of MSE walls are being constructed. Now, it comprises of the foundation. Foundation is the natural soil, and then we place the select fill. So there are specifications given by, this is available in IRC code also. IRC has given the specifications, what should be the properties of that fill. Normally it should be granular material, and the plasticity index should be this, fine should be this, all those specifications are given. And this is the retained backfill. So in this limited portion, we go for this reinforced backfill. So this facing may be in the form of the blocks or in the form of the panels like this. Then we attach the reinforcement. So the reinforcement earlier we used to go for the metal strips. Nowadays we are going for the geogrids or maybe geosynthetics. So this mechanically stabilized earth wall can be constructed. So I will not be going in the details of that. Then another technique is the soil nailing. Now soil nailing is a technique to reinforce and strengthen ground adjacent to an excavation by installing closely spaced steel bars, which are called as nails. Now normally in this case construction starts from the top and we go down. Now, the excavation is done in the limited heights of maybe 1 to 2 meters, depending upon the type of soil available. Now, it is an effective and economical method of constructing retaining wall for excavation support of hill cuts, bridge abutments, and highways. So the nails are subjected to tension, compression, shear, and bending movements. This is a photograph showing how the soil nailing is done. So here in the smaller heights, this excavation is done, then this hole is drilled, and then the nail is placed, and then it is fixed, and then after that the second, and then in stages we go from top to bottom. So special equipments are required for all this process. And after this construction is over, you can see a vertical or near vertical wall using these nails. So you can see here, these are the nails, the top of the nail with this piece. Now it can be used for the protection of this hill cut, or just near the railway, protection of the structures which are on the top of this, or it can be used for the embankment near the over bridge. Okay, so that can be used, or it can be used for the deep excavations without affecting the stability of the already existing buildings. Now, this is a typical soil nail detail. So we have got the hole, drilled hole, and then we place this nail, and it is kept in position by the centralizer. And after that, it is properly grouted, and then it is fixed with the by nut and bolt. Plate is fixed. It can be attached to the masonry wall if suppose it is being used in the basement for the basement protection, or otherwise we can go for the, or it can be properly short-treated also. It can be properly short-treated also. So this is the process which is depicted as shown by the slide, that we first excavate in limited depth, let us say 1 to 2 meter, and a platform is created so that this machine can come and we can place this machine here, and this slope can be near vertical or it can be vertical also, okay, depending upon the type of material. So this excavation is done. On this side, you can see these are the nails which will be inserted into the ground. So after that, by using this machine, these nails are inserted into the ground, and then grouting is done. Now after that, once this complete process is over, so it is done in steps. Once this process is over, now we can place a reinforcement, and we can place the, even we can do the short treating also to get a vertical, smooth vertical face. So this is how this is done, and finally you will get this complete soil nailed wall, you can say, or the soil nailed slope constructed. Okay, and whatever is the structure above, that can be protected well. Another method is the stone columns, which are also termed as the grinder piles. These are composed of compacted sand or gravel inserted into the soft clay foundation by displacement method. The ground improvement by compacted granular piles is termed as the composite ground. On loading, the pile bulges into the subsoil strata and distribute the stresses at the upper portion of the soil profile, rather than transferring the stresses to the deeper layers, like in the case of pile foundations. So you can see this is these figures I have taken from the IS code 15284. So there is one code devoted for the stone columns or the grinder piles. Now there will be different type of failures. If suppose we have got a long stone column with firm or floating support, then you will be getting a bulging at the top. And the resistance offered or the strength is improved by this particular, the confining pressure is applied from the surrounding material. Okay, so using this, there will be increase in strength. Or it can be a shear failure if you have got short column with rigid base, or it can be punching failure if you have the floating column. So here different type of loadings can be applied. It can be loaded on the larger area, larger than the diameter area of the stone column, or it can be loaded only on the stone column. These are some other descriptions in which, let us say you have got very soft soil overlaying the soft clay or silt, then you will be getting this shear failure. Okay. Now, if you have, let us say, a very soft clay which is sandwiched between two stronger clay, then there will be bulging here. Okay. So there are various stratifications, and we can use these stone columns in different type of stratification. So the critical pile length is normally that is actually the length of the bulge which is taking place. So here it is the radial stress which is offered by this particular soil, and we can find out the ultimate carrying capacity of this particular stone columns. These stone columns provide path for pore pressure. So the material which is being used, that is a stiffer material, and also in addition it provides path for the pore pressure reduction and lateral confinement of soft clay layers. So bearing capacity is greatly enhanced. This may be provided in areas where subsoil layers consist primarily of saturated soft clay more than about 3 to 5 meter thick, and where the required stringent consideration of settlement control cannot be satisfied with conventional removal or replacement of the soft clay. So there we can use. So after stone column treatment, the embankment with non-compressible fill can be constructed to its full height continuously without further. So the large portion of the applied load is resisted by relatively strong stone column and remainder by the cohesive soil which is available. Now, I have already explained the vibroflotation. So this vibroflotation is used for the construction of the granular pile also. That is also used. Now this is the vibrofloat, right, which is being used. So these are different parts of the vibrofloat. This is the nose cone with hole for bottom water jets. Okay, and then vibration section is provided here. So this is how the stone column is constructed. Now, starting from the preparation, then penetration, then we place the granular material properly compacted, and if it is, let us say, a layer sandwiched between two stiff layers, then there will be bulging here, otherwise bulging. Nowadays, we are also going for geotextile encased stone columns. Now here in this particular case, it is the ordinary stone column. Now when you apply the load, there will be bulging of the material because the material surrounding is soft soil. And in the soft soil itself, we can go for encasement of the, so normally we go for the geotextile encasement. Now research is being done for the geogrid encasement also. So here we are nowadays using this geosynthetic encased stone columns also. So these control stability, reduce settlement, and speed of construction. So these are widely used as columns supporting test embankments on soft clay deposits. Now this is the sequence in which construction is done of the geosynthetic encased columns. So here there is a pipe. So in this photograph also you can see this pipe is attached here, and it is, tip is closed. Now when you take it out, then this tip is open. So here by vibrating down, we push it to the ground. So when we push it to the ground, there will be compaction of the soft material. Once it is entirely pushed, then we place this encasement ring track. So here you can see this white one in the photograph on the side. That is the encasement. And after that, it is filled with the sand or gravels here, and it is properly compacted. And compaction is done by the vibration. Under vibration, it is compacted, and we keep on pulling it. And finally, you get GEC completed. So here, these two are the photographs, how these GECs will look like. We are also using composite piles. We are also using the combination of the piles with the granular piles. Okay, piles with the granular piles. There are various combinations. So these are the application of stone columns, tank foundations, highway embankment, even railway embankment, and the foundation of the reinforced earth walls also, and individual footing. Okay, so there are various applications of the stone columns. Now, another technique of construction of the stone column, it is the ramming technique. It was actually suggested by CBRI, Central Building Research Institute, and they have used this particular method. It is a very simple method. First boring is done, then material is placed in layers, and then it is properly compacted, and you get a compacted. Then sand compaction piles. Now this is again sand compaction piles. Now the procedure is driving casing into the soft ground, compacting sand pile. So in place of the granule, we can go simply for the sand with drying casing, and then we complete this particular. So okay, so I will be discussing this case study and example, which is a site in Jorhat, Assam. Groundwater table was at 1 meter below the existing ground surface. There were intermittent layers of clay and sand. Applied load intensity 10 ton per meter square. Proposed foundation was raft of size 20 meter by 20 meter. Depth of placement of foundation 4 meter. Saturated unit weight of the soil 19 kilonewton per meter cube, E 0.8, compressor index 0.2, and then contained shear strength was 35 kilonewton per meter square. So the total thickness of the layer was 18 meters. Foundation has to be placed at 4 meter below the ground surface. The load which is to be applied is 10 ton per meter square. Raft of 20 by 20 meter. So the calculation of settlement was done based on the value of compressor index and the wide ratio, thickness, and all these layers were divided into 12 layers, 1.5 meter thick, and the consolidation settlement was estimated as 656 millimeter. So for that, design for stone column was done. Diameter 0.6 meter, facing 1.2 meter, and length was 18 meter. So capacity based on bulging was determined as 8.68 tons. Based on surcharge effect, it was 3.12, and capacity provided by the intervening soil, it was 8.33 tons. So the total safe load carrying capacity of the stone column was 20 tons. And with the stone columns, the time required for 90% consolidation was 19 to 20 days. For about 90% consolidation, it was reduced to about 19 to 20 days. So after 20 days, the consolidation which has taken place 590.4 millimeter, and remaining consolidation after 20 days will be only 65.6 millimeter, which is less than the permissible limit. So in view of this, it is concluded that when ground is treated with stone columns, about 590 millimeter settlement will take place before the construction, and therefore post-construction settlement is within the permissible limit. So one can save the time and cost by providing the raft foundation on stone columns in place of going for the pile foundations. So again, in the stone column, a blanket is laid over the top of the stone column, compacted to a relative density of 75 to 80%. Thickness is about 0.5 meter. Okay. But in stone columns also, we suggest that we should go for the loading test. Like we go for the high load test. Initial load test should be performed at a trial test site to evaluate the load settlement characteristics, and the test should be conducted on a single and also on a group of minimum 3 columns. So this is the arrangement. Now this arrangement is given in IS code. So this is the on the single column or on the group of columns, this test should be conducted. And this is how the test is conducted. So here you have got the stone column and a sand blanket of 30 centimeter thick, well compacted sand blanket is placed. And finally, as we conduct the plate load test, we conduct this column test. This 30 centimeter thick is minimum. Now, in case of high water table, water level during test should be maintained at the footing base level by dewatering. So this is the procedure which is given for the load test. The cantilage should be minimum 1.3 times the maximum test load. Load settlement observations should be taken 1.5 times the design load. Okay, and the stage of loading is given when the settlement is less than 0.05 millimeter per hour. Load test should be considered acceptable if 10 to 12 millimeter settlement at design load for single column and 25 to 30 millimeter. Now, there is another case history, but I will not be going in the details of this because already 1 hour is over. So here, this is another case history given by Ajay Ghosh. In that particular case, it was not possible to go for PVDs, so they have gone for the stone columns, and they have found that with the use of stone columns, they could construct the new embankment with stone columns. So this is the final construction. Okay. Now another method which we use is the ground improvement by geosynthetics. So this geosynthetics is a generic term encompassing all the polymeric materials used in contact with soil or rock, or any other geotechnical material in civil engineering application. There are various purposes like can be used for reinforcement, for drainage, for filtration, for erosion control. There are a number of products which are available, starting from geotextile up to the geosynthetic clay liner. So the geotextile, these are the seed-like material made up of natural or synthetic yarn. So this is a photograph showing the geosynthetic. These are flexible and permeable, appearance similar to the regular fabric. Now these are classified as woven or non-woven or knitted or stitch bonded geotextile. Then we have got geogrids. So these geogrids are used either in the foundations or in the pavements. There are various types of geogrids which are available. 1D, 2D or maybe 3D geogrids are also available. So here these are the biplanar, these are the triplanar geonet or the other type of geonets. So we can, in place of, there are different uses of geonets. Geonets are different from geogrids. Now geomembrane. Now this geomembrane is impermeable sheet made up of one or more synthetic material. They are flexible in nature. Due to its extremely high permeability properties, it is used as a flood barrier. Now, if you have heard the name of the Malana hydroelectric project in Himachal Pradesh, very near Kullu, now they have used this geomembrane for creating the reservoir. Then we use the geocomposites, means if you are using more than one form in combination of geosynthetics, then these are called as the geocomposites. So we can make use of geogrid and geotextile, right? Or prefabricated vertical drain, that is also the geocomposite. Geosynthetic clay liner. So in this, the bentonite clay layer is sandwiched between thick non-woven geotextile. Geotextile encased clay liners are stitched or needle punched through the bentonite core to give higher shear resistance, and when hydrated, they are effective as a barrier. So often used in conjunction with the geomembrane. This PV, these I have already explained. Then another is the geocell. So this geocell is being used in the construction of roads, especially where we have got very poor soil conditions. So these are nothing but three-dimensional honeycombed structure formed by joining the polymeric sheet strips in a cellular manner. Now these are the pockets of geocell are filled. These pockets of geocell are filled. Either you can fabricate at the site, or these are the fabricated material also available. So you will have to simply spread it on the ground. So the geocell help in spreading the applied loads over a large area and provide excellent support even under cycling load. So this is how the construction of the geocell is being done. So to construct embankments and soft soil with the inadequate bearing capacity, geocell mattress is a unique method of ground improvement. The incorporation of a geocell foundation provides a relatively stiff foundation. So I will not be reading all this procedure. This procedure. Now the incorporation of geocell mattress creates an embankment foundation with the following characteristics: rough interface between the mattress and the soil foundation due to granular fill, and a stiff platform to ensure both an even distribution of load, right? So these geocells are used as the ground improvement technique. So here, this geocell can be constructed in field, it can be fabricated, and then granular material is filled in these boxes and it is properly compacted, right? Or you can go for prefabricated. Then geopipes is another material which is perforated or solid wall polymeric pipes placed beneath the ground surface and backfilled, and it can be the water which is coming into the pipe can be drained out. Geofoam, this is the low density network of closed gas filled cells made by expansion of polystyrene foams. Now these foams can be used for the approaches. Geofoams can be used for the approaches, as well as you can use it as a filler material behind the retaining wall. Now once you do that, then the earth pressure will be reduced considerably, and you can go for a thinner section. Then geotube. Now these are geotubes are used especially for disposing of the material which is highly higher in the chemical content, etc. So these geotubes are also used, and these geotubes are also used near the seashore. So the functions, as I said, it can be used as a barrier, geosynthetic, as a drainage, superficial erosion control, filtration or protection, reinforcement, maybe separation. So this is the table which gives you idea which particular material, which type of geosynthetic can be used for all these type of. So these are the roles of geosynthetic. Like it can be used as a separator material. So this is the separator for filtration. So many theoretical and experimental studies exhibit that inclusion of geosynthetic results in increase of bearing capacity and reduction of total and differential settlement. So here, this is one of the case study for GeoGrid reinforced granular pad foundation. It is for the waterfront quays in Hamilton Harbor. Were constructed by placing a fill within a perimeter steel sheet pile bulkhead. Two 31-meter diameter liquid storage tanks were to be constructed on the site. The stored liquid applied a load intensity of 120 kilopascal. Based on borehole data developed in an initial geotechnical investigation of site, it was recommended that the tank loadings be supported on either stone columns or end-bearing pile foundation. So the cost of these foundation systems was prohibitive to the development. So additional fieldwork consisting of 3 soundings with a flat plate dilatometer was carried out to better define the geotechnical properties of the soil profile. Now, using these data, a foundation design was prepared, which consisted of construction of a GeoGrid reinforced granular pad. So, post-construction monitoring of settlement of the tank foundation showed that settlement of the foundation was within tolerable limits. So, this is the site plan. So, here, this is the study area, and it is shown the exploration plan. So this tests were conducted. This was the subsoil profile. Now you can see this is sandy silt, silty sand, fill. Okay. And below this there was silty clay and clayey silt. Now standard penetration test, you can see very low value along with the moisture content. Moisture content was very high. So this is showing the SPT and this is showing the moisture content. Now here this is the plan view of the GeoGrid layout. Now these are all the GeoGrids were placed in this particular fashion. Now this is how the GeoGrids were placed. All the GeoGrids you can see, and then it was properly compacted, and this is the photograph of the completed tanks. So the construction of an engineered pad of reinforced granular fill of layers of relatively weak compressible fill and native soil resulted only moderately differential settlement, which was well within the tolerable limits. And by using that, this particular method, there was a lot of. Okay, there is another case study, but again, I will skip this. You can see this photograph, how the pad is being fed. Then we have got ground improvement by chemical treatment. So I will go a little fast now. So these methods are permeation grouting or jet grouting, deep soil mixing. Nowadays we are going for this deep soil mixing, especially in Singapore. This particular method is very effective also, and it is very popular. Lime columns, earlier we used to go for lime columns or maybe by fracture grouting also. So the key issues involved in chemical treatment are soil grout compatibility and reactivity, operational parameters, column verticality, and weathering effects. So injecting or adding admixtures such as cement or lime slurry to the soil in terms of permeation, compaction, or jet grouting. So it fill voids, increase compressive strength, increase the modulus, increase the tensile strength, and form the seepage cutoff. Now this is how the chemical treatment is being done. So here is the photograph. of the permeation and compaction grouting. Now, if you have got the granular material like this, then it creates barrier to the groundwater flow, and it also used as the underpinning foundation. Now, if you are going for compaction grouting, so this will displace this material, so it will get compacted, and you have got a solid stiff type material. So you can use. Now in jet, this is jet grouting. So again, using the jet grouting, there will be a grout valve type of thing, grouted column which is formed. Okay, so it will reduce the settlement. This is compaction grouting. This is permeation grouting. Now this is one of the case study, by which the groundwater barrier using jet grouting was done on the Polavaram Dam project. Another is the deep soil mixing. So again, I will not be going into the details. So there are different applications of the deep soil mixing. Now chemical treatment, you can go for chemical treatment also, especially for the peats. Or electro treatment, like ground freezing or vitrification. Then biotechnical stabilization, especially for the protection of the slopes. Now this is the different ground improvement methods which are available and which can be used for what particular type of soil. As I said, all the methods cannot be used for all type of soils. For some of these soils, different methods can be used. Okay, so with this, I complete my presentation. Although I have got few more slides also after this, but I will not be going in the details of.
Yes, thank you very much, sir, for a very nice presentation. Any question from the participant side? Any queries? Anyone want to discuss any doubt question? Then feel free to discuss. Otherwise, participant may write the question or query to me as well as Mr. Rohit Kumar. We will reply to you. And thank you very much, sir. Thank you very much, sir. You have touched all the dimension related to ground improvement, and especially you have very nicely present field testing and some case study related to Jorat and other study. Thank you very much, sir. Thank you, sir. Your session is very
actually this is nothing but the abstract of what.
Yes, sir. Yes, sir.
Ground improvement techniques are available.
Yes, sir. Yes, sir. Yes.
And I'm sure most of you, I can see Dr. Javed also.
Yes, sir.
Okay, so
I think
most of you may be knowing what these methods are. Okay, thank you.
Okay,
so
thank you very much, sir.
Thank you for giving me this opportunity.
Yes, thank you very much, sir, for your time, and thank you very much for accepting. Thank you, sir.
Okay, okay. So now I will leave.
Yes, thank you very much, sir. Okay, thank you all the participants. We will again together here 2:30 around 2:30 p.m. and participants are requested to please join before 5 minutes, and after 2:30 we will hear for the session the Professor C.S. Solanki sir from SVNIT Surat. Okay, thank you very much. Attendance I will share in the chat box and group also. Thank you very much.